Right here.
I don't know. Over there. I crossed him off. All right. Hello, girls. Mallory and Josie. This is 8-4. We're going to get done with notes today because it is example 1, example 2, and there's no even backside. That's so exciting. Tuesday, right before I ditched you guys, I think they wrote down, they plugged these into a calculator, and they got X bar, N, and S. Those are the 3 things that we need to know for this problem. So there you go. 8-4. Ready? This has to do with standard deviation. They say variance also. You can do variance. I just usually do standard deviation. So there is that. All right. Here we go. This is the formula that we need. N is N, S, and sigma. Let's talk about the difference between those two. Which one is, what are they?
Standard deviation.
Standard deviation for what? Samples top, population's the bottom. The bottom one is what you use for the claim and what you use for H naught and H1, right? Okay, so we use sigma just like we use mu and like we use P, right? Okay, here we go. Listed below are the heights for female supermodels, and they give the names of these supermodels. I'm not going to read through all those. Okay, now, here is what we are testing. Ready? Supermodels are what for height? Tall, right? And so what they're typically they're tall, right? Tall and skinny, right? And so what we're doing is we are testing the standard deviation, which is going to tell me what? How much their height deviates, right? Because if it's a low deviation, then they are all about the same height. Does that make sense? Okay? We want them all to be kind of the same height, all the same body build and everything, because then we can put a random outfit on any supermodel and it will fit them because they're all the same size, right? Okay? And we don't have to do much alterations. So use a significance level of 0.01. I'm going to write that down. We're going to draw a bell curve here in a second. And my hypotheses. I don't have those written down for some reason. I don't know why. We're using sigma. And the top one's always equal to, but equal to what?
7.5.
7.5. You see that in the paragraph? Okay, and we are to, I always look for the words, to test the claim that, blah, blah, blah. Everything that follows the words to test the claim should go in my hypotheses. So the standard deviation is less than 7.5. So the bottom one is less than 7.5. And that is my claim, right? The claim goes with the bottom one. Some of you guys just draw arrows, which is fine. Okay, I have my bell curve, okay? And they ask for p-value method. I'm going to only do this critical value method, and then I'm going to do this confidence interval method. So we have a critical value and a confidence interval method style. Got it? We don't have p-value for this one or for mean. I mean, you can do it, but you have to type stuff into a calculator, and I don't want to do it that way, okay? All right. Less than, greater than,
Less than.
whatever. We have a left tail that we're shading in, okay? And how much percent goes in there?
0.1.
1%. Okay, which means, and we have like an imaginary 1% over here, which means we have 98% in the middle. Okay, and which chart are we even looking up?
Height.
The chi-squared chart. Chi-squared chart. If you want to write that real big. Chi-squared chart. For standard deviation, no matter what. No matter what. Okay, 98%. But we also need to look up the chi-squared chart. We need to know the degrees of freedom, which is
1 less.
15, right? 15 degrees of freedom and 98. Give me your two numbers.
5.229.
Okay.
And
30.578.
Yep.
578. Okay, now we don't care about the 30.578 because that's not going to be like on my radar, but I always mark both of them just because. Okay, so we're really going to be comparing to the 5.229, right? Okay. All right, where does 0 live?
Not even on the chart.
This is the only time that 0 doesn't live in the middle when we're doing critical value style. 0 lives over here, right? Like off the chart, right? 100 lives over here or whatever, right? Okay. So that's, this method is kind of like doing the p-value method, like the percent, right? Okay. Just because the scale for the chi-squared chart is just weird, weirder than the other one, right? The chi-squared chart is the only one where we look up two numbers instead of just one. Got it? Okay. All right, now what do?
Plug it into the equation.
The formula, right. I need to know this guy. Okay.
15.
So I've got chi-squared is equal to
Times 1.1.
n minus 1. I'm just going to write the whole thing down so I can zoom in, okay? So this guy, n is 15, or 16. So if you want to just type in 15 there, that's fine. S, what is my S? Holy moly. If that doesn't tell you right there what your answer is going to be. Do you know what your answer is going to be? What are we comparing 1.844 to? Yeah, because we'll say it's less than. 1.844 we're comparing to 7.5. Do you think 1.844 is significantly less than 7.5? Are we talking about standard deviation? I think so. I think we're gonna end up circling this guy and crossing that one off, but we'll see. Okay. 1.844. And don't forget to square it. If you screw up, that's gonna be where you screw up. 7.5 squared on the bottom. Okay, there you go.
We do that, then take the square root of it, right?
No. Chi-squared is left as chi-squared because the chart is labeled chi-squared. Yeah.
Okay, so
What do you get?
0.907,
0.907.
Yeah.
Woo!
right?
Where does he live?
I think that's what she said. All the way over there.
All the way over here. Okay. So is he in equal to land or is he in less than land?
Less than like.
He's in less than land, right? He's in the less than part of it. So we go this and we go that, which is exactly how I thought it was going to be, right? 1.844 is, or 84, whatever, is way less than 7.5. So I'm going to say that. All right, so we write reject H naught, and the claim is true. Now, what does that mean about our supermodels? They are not deviating a whole lot. They are about the same height. Yep. Right? They have very, very, very small deviation. They are exactly the same height all the way across, which is what we want. Yeah. So, I don't know if they get in trouble for that now. It's 2025 and there's new rules that apply because of, well, DHS is not, or whatever, not DHS. What is it? DEI is no longer a thing anymore, I guess. So maybe they are able to discriminate against these people and only hire specific people for supermodels. Yeah. Yeah. So, I don't know.
I think the threshold is like 5'8".
Yeah.
It has to be like
Mm-hmm. Yeah.
115 pounds. Yeah.
5'8".
And like 5'8" or what. That's crazy.
But you can't be like 6 foot.
You can't be 6 foot, so you have to be 5'8" to 6 foot.
You can't be too short.
Right.
You can't have like wide shoulders.
Yeah.
Or like wide
Crazy.
Or
Crazy,
you
crazy.
basically have to be built like a 2 by. Yeah.
I don't know. Crazy, crazy. All right. Okay, so now we have the same thing. We're doing again. Same data, except we're doing it confidence interval style. All right, so if we want to just copy, I'm just going to copy some of this information down. If you don't want to, you don't have to. It's just directly above. But we're comparing to 7.5, and we're saying less than 7.5, and the claim goes here, and here's my bell curve again. Whoa. And I have my left tail shaded. I'm just recopying all this stuff down because it's the same. If you don't want to do that, that's fine. You can just draw an arrow. I'm stalling for just a second. 30.578. All the same information applies, except we're doing this confidence interval style. So we're doing this formula right here, right? This is like this guy lives between, sigma lives between these two numbers, right? And normally this is set up so that we have like x bar minus the error and x bar plus the error, right? Do we remember doing this? Or we have p minus the error and p plus the error. Actually, it's p hat, right? And that tells us what he lives between, p and mu, right? For all of the other confidence interval guys, we've done this. So we've done the error and we've added, subtracted. This is the one where you don't have an error, you don't add and subtract, you actually have to do these two sides, right? Okay? So,
Yeah, this is where you have to switch.
yep, and you switch the right goes on the left and the left goes on the right. So we've got this guy here. And n minus 1 would be 16 minus 1, according to the formula. If you want to put 15 in there, that's fine. 1.844 squared. It's like the same formula. 16 minus 1, 1.844 squared. And my,
The left side is 30.57.
yep, these two numbers. The two numbers that we looked up above there, they just get switched. So the 30 number goes over here. It wouldn't be a bad idea for you to try to plug these in to make sure that you get the right answer because some people are like not getting everything underneath of the square root and you get weird answers. So
1.29.
Yeah.
for the bottom number,
3.12.
1.29 and 3.12.
Yep.
Okay. If you want to check, that's what we're going for. 1.29 and 3.12.
I got the 1.29.
I got 2.12.
Perfect. Okay, now, how do we use that to draw a
We
conclusion?
have to see if the numbers.
So I'm looking at this guy, and I want to say, okay, if we know that sigma lives between this guy and this guy, does that mean he's equal to 7.5, or does that mean he's less than 7.5?
Less than.
This entire region is completely less than 7.5. So again, I get the same results. I circle the bottom, cross off the top, right? So it's again, reject H naught.
Claim is true.
Claim is true. Okay? Got it? Is this making sense?
Now you're
Like
gonna
finally after the fourth section, you're like, yeah, okay, I get the hang of it, right? Yeah, not too bad. It's just a different formula for every section. But it's the same process every single time. Okay?
Okay.
Good. If you have two tails, you split the tails, right? Or you split the significance level. Otherwise, you shove the whole alpha value into that one, right? Okay.
Which ones do we do?
Which ones do we do? Can we do? Has anybody started? Reese, have you started with homework?
But I only did number 1.
Okay. Which style did you do it?
I'm gonna do it.
Okay, so let's do 1, 2, 3. Let's do a critical value style. So that's like example 1, and then we'll do 4, 5 as confidence interval style. So that's like example 2. Okay. So critical value on the first page, confidence interval on the second page. So like example 1 on the first page, example 2 on the second page. No. This should be the homework. The review should be next after that. There's 1 page of homework. If you did not get this written down on number 5, Ellie or maybe I don't know who else did this on Tuesday.
I know Ken was here.
Kenzie.
I don't know who else did it.
X bar 73.3, standard deviation 2.08, and N is 20 for those guys if you want to write that down. They did those all for you. Otherwise, all the rest of them I think should be ready to go for you. Got it? Okay, I'll stay there. All right.
What is okay?
Yes, sir. Yes. Okay. Anything else I need to announce for the good of the cause of Mallory and Josie? Can I stop? Okay. All right. Goodbye, girls.